In 2023, question 1 was a directed graph represented by this adjacency matrix. We can see here starting with A. A has a loop at A. A goes to A. Give it a loop. A goes to B 2 times, or 2 different paths. It's a directed graph, so we do have arrows. We can put an arrow or not on the loop because it only has one place to go. A doesn't go to C, it does go to D once. A to D. Then we're on to B. B doesn't go to A or B, it goes to C. B goes to C. B doesn't go to D, and it goes to E at the end. B to E. B to E, on to C. C has a loop at itself. It goes to B. It also goes to C. C has a loop at itself. Sorry, C goes to A was the first one. Missed that. C goes to A. C goes to D. It goes to E in 2 paths. C to E in 2 paths. 1, 2. And then onto D, there's zeros all the way across, so D just goes to F. D to F. E, zeros all the way till 2 loops at itself. E, 2 loops at itself. There's 1. There's the second. And then F has zeros apart from just 1 path to B. F to B. So a lot going on here. So that's my graph. The cycle, a cycle has to be complete and end up back at the same place. A cycle which starts at node B. Okay, there's probably a few of them. Node B, we could go to C, back to B, C, B, B to C, and back to B will be 1. We could go from A to B, and then B to C, C back to B, and we can't get back to A that way, so that wouldn't be 1. And what about different color? If we go from B to C, when we get back to B, we can go to D, and then we can go to F. It's nearly a circle here, and then we can go to B, so that's nearly a perfect circle. B to C to D to F to B will be another option here for a cycle starting at node B. And in part 3, how does a directed graph differ from an undirected graph? Well, a directed graph has arrows, and an undirected graph has no arrows. We could also use the word direction and no direction for part 3. Part B of this question is integration by parts, or otherwise, but let's use integration by parts and see where we go with this one. ds would be equal to 2t e to the power minus t dt. So if we integrate ds, we get displacement s. So we need to integrate by parts 2t. That'll be 1 part, e to the power minus t dt. So let's let u equal 2t. Integration by parts is u dv is uv and v du. So we have to let dv in this case equal e to the power minus t. If we differentiate this with respect to t, du dt will be equal to 2, so du is equal to 2 dt. And if we integrate dv, we'll get v. So we integrate dv and integrate e to the power of minus t, we'll get v is equal to e to the power of minus t times the minus 1, differentiating the minus t. So v is equal to minus e to the minus t. So if we sub this into the formula, we have u v minus the integral of v du. So u was equal to 2t, so we have 2t times v, which we've gotten here, minus e to the minus t, and then we have minus the integral of v, which is minus e to the minus t, times du, which is 2 dt. So I'll probably factor out the 2 here. I'll do the minus 2 by the integral of minus e to the minus t dt will be minus 2 times, we've integrated this already, minus e to the minus t by minus 1, which will give 3 minuses, so it's still going to be minus 2e to the minus t. So we have 2t minus 2t from here, minus 2t e to the power of minus t, and we have minus 2e to the minus t. So we can say s is equal to minus 2t e to the power of minus t minus 2e to the minus t, and we have to have a plus c in here, plus c. And they do tell us in the next part that s of 0 is equal to 0 to help us calculate c. So we're going to get minus, well actually I could maybe tidy this up a little bit first. I could factor out minus 2e to the minus t, and that would leave inside just t plus 1 plus c. So this will be equal to 0 if we put 0 in. So minus 2e to the power of 0 will be times 0 plus 1, so just times 1 plus c will be 0. Anything to the power of 0 is 1, so minus 2 plus c is 0, so c is equal to 2 in this case. And in the last part, we're asked to calculate s of 3. S of 3, so if you just sub s of 3 into minus 2e to the power of minus 3 times 3 plus 1 plus c is plus 2. What's this equal to? S of 3. And I'll give a correct 1.6 for the final part of this question.